So I have this bat file that, I don't know if I should show the bat file. It's right here though, I think. Let's see here. We're on Windows, that's why it's a bat file, and it just compiles and links, creates this cart.ns. So yep. And so that's what that does. And it takes a argument as well. I'm working on this one called 02.s, whatever, that's just the name I give it. And I'm just checking that this is, yeah, not changing. Just display some text. So let's see here. We've got A, we've got B, we've got C. I want D. So D, I guess, should have ones like that. Yeah, we're only going to do capital letters. Let's try here with zeros. Should be a D coming up. So a sprite that's this column is the sprite numbers 0, 1. So it used to say hello. So, but now it's A, B, C, D. D looks like an O. That's a problem. Oh, hey, Young Ring, how's it going? D, I think, looks like an O. Also, I should add these numbers in the comments. Yeah, D looks like O. How do I stop that? Maybe having zeros here. So you can graphically see the letters in the ones and zeros. If you look, there's a C. If you look at E, if you look at the ones and zeros, you can see it, the pattern. Here's L. So let's do 0, 1, 2, 3, 4. Compile. It's not doing what I would expect. Let's see, what's the last thing I changed? Yeah, I changed these. Let's just change all of this to zeros, or a few of those. Compile. Something wrong. Something wrong. Let's remove cart.ns. Recompile. I don't know, maybe this FCUX is messed up. Yeah, it's assembly. Okay, let's see. I have something to quickly bring up the emulator here. A little script. Where's my emulator? Oh, we got some kind of problem going on. I've introduced some kind of bug, so I'm just gonna undo a bunch of stuff. Maybe this area is having too much data. It's not supposed to have that much data, maybe? I don't know. Let's try. Weird. stopped working. Let's go back further. Why does it have some kind of problem with that? Alright, let me just test something. Let me compile a different one. Okay, how about number 1 here? Yeah, nothing's working anymore. It's very strange. Hawaii. Something strange happened. Alright, maybe I'll try number 5. Wait, I know why. Is that why? Yeah, this emulator has a problem when this is not the primary monitor, I think. Let me see something. Okay, I need to... Yeah, it doesn't display when it's not the primary monitor. It's real weird. Let's make sure this is the primary... No, make this the main display. Okay, it's displaying now. Okay, that was it. That's so weird. What does bytecode do in assembly? Well, whatever you do in assembly, it's going to depend on the compiler. But all this is doing is, you know, the assembler is going to compile the code, and so here it's putting the bytes that correspond with NES, the letters NES. So the first byte will be something corresponding to an N, then E, then S. Now this is hexadecimal, so 1A is going to be, what is that? That's like 26. Will be in this 4th byte, 5th byte. This is the number 2, then the number 1, and so on. Now this byte here, this little percentage sign is how we write binary with this assembler. So, you know, 1 byte is 8 bits. And we've got the last bit here, or the least significant bit is 1 here. So this is a header, so it's not really important to understand what it does. But it's very common that different files have some kind of header to give general information about the file. And this NES thing is used for emulators. An actual, I believe, a actual Nintendo cartridge will not have this, not need it. So if you want to run, put the stat on an actual Nintendo cartridge, you need to get rid of it, I think. Yeah, so that's what the byte thing does. Let's see, let's go back here. Okay. So it says AB. So let me try to redo what I can here. And we'll compile. We'll drag it in there. Okay, so we have the D is looking weird. I don't know how to make a D that doesn't look like a 0 or an O. I guess it doesn't really matter, huh? But I think it's looking a little thin on the top and bottom. So that's our D. So we've got A, B, C, D, E. We want F, obviously. What are you trying to program? I'm just trying to get decent at programming Nintendo games. So E is 4, we'll just call this 5. Needs to look like F. figured I would want access to the letters, I looked online to try to find somebody who's already done all this stuff, and I wasn't able to find anything, so do it myself. Although this program that I'm running, where I'm editing the code here, was from a tutorial, and they had hello spelled out, so that's why there's L and O here. So A B C D E F G, then H I J K, and then L. So let's see here. So 5 is F. Seems to look like G. Maybe like this. Maybe I'm not. Yeah, I think that looks like a G. A, B, C, D, E, F, G, H. H, we had H before. I don't know what happened to it. Did I get rid of H, I think? Yeah, I got rid of H. E, F, G, H will be number 7. I know that. I mean, what are you trying to get with this code? Well, I just want to be able to write all the letters. That's all. For starters. So let's actually, to make H, let's start with E when we make H, I guess. And these bytes here are just some filler. I'm not sure why it has filler there. E, F, G, H. Okay. What's closest to I? I don't know. So I think I want the middle to be switched on. Ones or whatever. So that'll be these two, I guess. We're just doing capital letters only. Oops. Okay. So let's test some of these. So nothing will have changed just yet. Although I think the D changed. Yeah, the D is just looking like a 0 now. That's not sure what to do with for D. Try making zeros. I don't think that's gonna make it really better. Looks a little weird. Anyway, forget about the D for a second. So this column right here is the go like this, yeah. This column is the numbers of the letters. This column is, I guess, the Y position, X position. So A, B, C, D, E. I think this is E, and it'll be F, G, H, I. So we can just have a look. F is looking real weird. E, F, G, H, I. The others look okay. So F we messed up. I messed up. I don't know what it's called, but what are you programming assembly in? Oh, yeah, this is Visual Studio. Yeah. Visual Studio Code, rather. A, B, C, D, E, F, G, H... F was messed up. Okay. Yeah. Should I make it all the way across? Might as well. That looks okay. F, G, H, I... J... Oh, J... I think that's a little weird for a J, to be honest. Let's do... I don't think that looks much better, but... Well, I don't think okay. I think this is gonna look a little weird, but let's just we'll check it later. A, B, C, D, E, F, G, H, I, J, K will be. I'm gonna write this in hexadecimal. So A. K, a little harder to make. Actually, let's go. I think it's also gonna look a little weird. It's K, A, B, C, D, E, F, G, H, I, J, K, L. This is now 0B. L, M, N, O, P. L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. M, N, O, P. Might as well do the numbers. So this was 0C, this will be 0D, 0E, 0F, 0, MNOPQ, R, S. You can't really see it, can you? Well, Visual Studio is not Visual Studio Code is not an IDE. So there's really not much. The syntax highlighting is not a very difficult thing to get for a language. That's all it's doing. I don't know that it's doing anything more than syntax highlighting and some auto-completion and stuff. Well, P, Q, R, S. T. STU V W X Y. Yeah, I wish it would have been nice if somebody had this online. Could have used 14, 15, 16, 17, 18. So 16, 25. There's supposed to be 26 letters, huh? But I start at 0, so yeah, it makes sense. Okay, now I need to actually make them. J, K, L, M. Making M. I'm a little lazy to make this look good, so I might just do... If I actually use this stuff to make something, then I'll start maybe caring a little more. I can always... so apparently these Western alphabet bitmap fonts, I don't think can be copyrighted. So I should be able to find them online. Visual Studio Code, I'm guessing like 10 years, I'm not sure. And also it's kind of annoying. What happened? Okay. I see, so with D, I can have these little rounded corners. And then, but only on one side. So that's O. So let's try to change D to look better. Actually, let's just make it by copying O first. This might make D look a little better. I don't know. Let's have a look at that. Oh, it's not making D right now, so D is 3. I mean, it looks better than before, yeah. It looks okay-ish. I feel like it could be better. What are those numbers like that for? These are binary, so each of these, so this is saying put this byte in the code, and well, it's going to put it in the final compiled program, and then so you know I could just have like dot byte 00 like this. So actually rather so this means number. So this would be put the number 0 there. This is number 1 and so on. Now but this is a decimal number. If you're using hexadecimal, which is, I always just use that, I guess. So this is the number 10. This is the number 15. And, you know, this is the number 16, 17, and so on. So you can do that. It'll just put a byte into the final program. So this is a way of just inserting data into the program. And then with this, it's binary. So, you know, byte is 8 bits. So this is 0 in binary. This is going to be 1. The number 2 looks like this. This would be 2 in binary, and so on. But I mean, what a number is in binary kind of depends on how your... I mean, it's just data, right? It's just ones and zeros, and how the program interprets those ones and zeros determines what number it is. It's going to be different if you have a system for handling negative numbers. That's going to look different. The common system for handling negative numbers is called 2's complement. And so, you know, program higher level language like C or something is going to handle that kind of stuff for you. It gives you types and all that. But with this assembly stuff, it's a little different. And yeah, so I'm literally putting ones and zeros to create the letters. You see here's the ones. The ones will create the letter C here. If you look at these ones here in this column, right? Do you see this letter C here? Anyway, I'll get rid of this byte. It's not complicated. It's literally the letter C. And if you are going to be a programmer, you need to understand what a byte is, that a byte is 8 bits. You need to understand what hexadecimal is, no matter what programming you're doing. This is just basic programming knowledge that you need to know. And you need to know what binary is. I mean, you can probably get away without ever needing to actually use binary, but a good programmer obviously needs to know that. It's just like really fundamental stuff. So, I mean, this program is not that long. So with all this data in here, you know, and the whole alphabet, we're getting less than 400 lines. So up until the data here, specifically for the letters, I mean, it's less than 100 lines. Now this stuff is related. This tells the Nintendo what colors to use for the background and for the sprites. The sprites here are just the letters. This part is telling the program where to position which sprites. So we're gonna flesh this out a bit. So this is stored a little bit weird because it's like, I think this is the Y value in the first column, or I guess it's the X value, but it goes down, if that makes sense. Maybe it depends. Yeah. Anyway, so I'm thinking this is the Y value, and over here is the X value. This column is the number of the sprite. So each sprite, it looks like each sprite is 16 bits, because there's 8 bits here, and then there's 8 bits of filler. I think there's different ways of doing that. I'm not exactly sure. I don't remember. But I'm just following the pattern. I mean, yeah. And so if I type this in 0, 1, so we got 0 here, 1, 2, 3, 4. That's going to be A, B, C, D, E. Compile, bring in the cartridge, A, B, C, D, E. And I can add a letter. So the first column is the Y position. So if, for example, I increase that, which all the other ones have the same position, and then let's do, let's do A here. So hexadecimal here. see what happens. So it made another letter that is, I further increased the X direction and also the Y direction here. So yeah, but the 4 is the same. Both of those are E. So we can go 5. Actually, I want to bring these. I want to type out all the letters maybe. So let's just start at 0 here and then see what happens if I go. I'm going to comment these out and see what this looks like. Maybe it needs more space. Or maybe it's... Where is it? I'm not sure. Let's just try 2 here. And let's try 0A. So that in hexadecimal, that's the number 10. Okay. How about the number 4? Okay, so it kind of gets cut off there. So trying to figure out where to start from. Maybe, probably, I'm guessing the number 8 for whatever reason. So let's try 8. See how that goes. That seems good. So for whatever reason, starting from 8. Now this next letter, let's try 12, which is it going to be C? I think. A, B, C. Okay. A little tight there, so D. Still tight. Or maybe we just straight up go to 1, 0. How's that gonna look? One zero is still too close. That's interesting. Okay. That looks all right. So we're incrementing by 10 because we went from 8 to 18. To 18. So I want to increment by 8. No, 10 rather. So 28 in hexadecimal. So I think I can just write this like this, maybe? I've never actually tried. Yeah, I think maybe this assembler doesn't like decimal numbers. So, let's think. 1, 0 is 16. I want to add 12. So I guess 1C probably. Looks good. ABC. So this is 12 and 16. Adding 8 is like adding 6. No, adding 10. I want to add 10. That's like adding 16 and then subtracting 6. Adding 16 and then subtracting 6 from C, I guess, is just the number 6. because 12 minus 6 is 6. That worked. So I'm going to add 16 and subtract 6. Add 16, subtract 6. That's adding 10. So it's going to be 3a. Okay, but I moved it down for some reason. Okay. A, B, C, D, E, F. That looks okay. G, H, I, J, K, L, M, N, O. I know we've gotten that far. Why did it? Oh, okay. So need to increment this value. And then we'll increment this. So 30 to 3a. So 3a. A is like 10. And we want to add, what was it? 10. I think that's right. So this should add one letter here. Nope. Because I changed the wrong one. Okay, this should add one letter. D still looks a little weird to me, but so 4, 4, 4, 4. So 4 plus, we're adding 10, so 14. Which is that D, I think. And then we will add 16 and subtract 6 from 14. So I think it's 8. A, B, C, D, E, F, G, H. What happened? Maybe, hold on. So it's not displaying I for some reason. I should be 0.8. Go back a step. Although the NES can only do so many sprites at a time. It might only be that it can display 8 sprites at a time. Is that a thing? How many sprites does the NES display simultaneously? It says 64, but I don't think that's right. $32? Ah, okay. If more than 8 are displayed simultaneously on a single line, this would also cause flicker. Okay, so 8 per scan line. Okay. I forgot, did you say you're learning assembly for making games or for changing Nintendo games? Oh, I want to be able to do both. Hacking the... We should call it hacking the ROMs. ROM hacking. Okay, so we've got 8 in one line, so we need to move to the next line here. So that's cool. We ran into a physical constraint here, so let's just try 1C for the next one. Okay. So what I'm going to do is I'm going to duplicate this on the row below it. Okay. And then I'll increment instead. So 7 goes to, so we go 8, 9, A, B, C, D, E, F. So A, B, C, D, E, F, G, H, I, J looks funny. K, L, M, N, O. Okay. Let's actually make P here. I think we can have this rounded. See how that looks. A little weird. So I want a little more juiciness here, I think. I'll just make it a little more blocky, I guess. I like blocky looking stuff. That looks better. Hacking? ROM hacking. So the files for these Nintendo games and Super Nintendo games and stuff are called ROMs because they're usually .rom files. So like let's see. On my desktop, well, yeah, they're ROM files anyway. So ROM. Because we have a decent looking letter P. Q is going to be a long line. Let's see if that looks like a Q. I think I should have a 0 here. Maybe a 0 up here too. A little rounded. We're not displaying the Q yet. Let's do a little bit more of the letters first. So that's gonna look a little weird. Probably. You have to go. All right. Thanks for hanging out. See you. Yes, that's hard to make. It's gonna look like a Z. Close enough for right now. A Z goes the other way, huh? Okay. QRST. U, V. WX. Hello, Cornflake. How's it going? How you doing? I'm making the letters for a Nintendo game. This is what I have so far. Although, yeah, I'm putting in the data for X, Y, and Z here. If you look, you can see the letters like in the ones and zeros. I'm inputting the data byte by byte here. This is supposed to look like a V. If you look at the ones as opposed to the zeros. So let's make an X here. X is gonna, okay, do a little bit of work. Something like, have you ever done programming? This is not how most people do programming. This is more of a hobby and a learning exercise, I guess. Let's see. Almost making this just look like an X chromosome. Well, since amazingly an X chromosome is in the shape of an X, who would have thought? I've been following tutorials, trying to learn. I might just have enough knowledge now to be okay. It was not easy. But I'm not good at making things move around yet. And that's kind of what I want to do today, but I saw that I don't really have a way of making the alphabet. And I'm probably going to want that. So we can only display 8. So I guess you can display like up to 30. I forget if it's 32 or 64 sprites at a time. But on one scan line, so one horizontal line, you can only display 8 sprites at a time. So that's why I did 8 letters per line here. If I go way up here, this is where it's called hello, because it's from a tutorial that just shows hello on the screen. Even showing hello world would have been too much because it would be too many sprites on one line. We had to downgrade to hello. But let's see. So this is the first line. This first line, I guess, is the Y value, the first column rather. So this is second. These 1Cs. If you know hexadecimal, those are numbers. Yes, indeed. So let's copy this and do another row. So 1C is the number, let me think, I think that's like 12 plus 16, 28. So I'm going to want these to be like this, I think. That will be the number 38. No, actually, let's just do 2C. Okay. Incrementing by 16 there for the Y position here, and then after F comes 1 0, 1 1, 1 2, 1 3, 1 4, 5, 1 6, 1 7. Compile. Okay, so A B C D E F G H I J K L M N O P Q R S T U V W X. Coolness. My Q looks. Some of those letters look a little silly, but I need to work on a bit. X. Only 2 more letters to go though. That's fun. Y. That'll look like a Y kind of. Z. Goes across. Okay, so we only need to add 2 letters. Yay, the alphabet. Hooray. Oh, isn't that exciting? Alright, I'm gonna stop here. Thanks, everybody. Have a good one. Bye.